Hello. So first I'm going to comment on the crystal growth so far. So this blue line at the top is how much of the liquid has evaporated so far. So we've gotten probably about a fourth is gone. And we do have some crystal growth at the bottom here. There's none on the sides, they're all on the bottom. They look to be about 1 millimeter wide on average, and they look very geometric, which is good. That's how crystals do form. They're clear, and I think progress is going well so far on the growth end of things. Environmental factors that could be influencing this growth. So because it's in a liquid solution, the temperature of the room as well as how much light the bottle is exposed to affects how the liquid evaporates. So my room is probably warmer than most other rooms, so that's helping evaporation, but I am keeping it in a dark place, so that's probably negatively affecting the evaporation because those incoming photons of light aren't helping to raise the energy of the liquid and having it evaporate. So yeah, some environmental factors. Pressure also affects crystal growth, but because this is atmospheric pressure, so we don't really have that as an option for changing that. So moving on to the percent yield. So we have our 4 equations at the top here that we went through in the experiment. So we started with 1.05 grams of the aluminum solid. We combined that with the potassium acid solution, and then I took the 1.05. I calculated a mole amount for the aluminum. We got 0.0389 moles. I just made sure real quick that was the limiting reagent in this first reaction. We also had this much KOH, so that was 0.2 moles, which would yield 0.05 moles of product here. So this is the limiting reagent because this is the smaller number. So because of that, using Stoic, these both have coefficients of 1, so we have 0.0389 moles of the product. So moving on to the second, we know we have 0.0389 moles of the aluminum hydroxide. So again, this just yields another 0.0389. We decided that the limiting reagent here is again this, because the H2SO4 has a 0.225 moles through here. Using coefficients 1 and 1, we know that the products here also yield 0.0389 moles. So moving on, we see a reoccurring theme here. There's just 1-to-1 mole ratios of all these things, and it all ends up being the limiting reagent. So we end up with 0.0389 moles of the final product, this. So then I used the 0.0389 moles, multiplied it by the molar mass of the final solid alum crystal, and we got a theoretical yield of 18.56 grams. Comparing that to the actual yield from the experiment, we had an actual yield of 11.15 grams. Using the percent yield formula, actual over theoretical times 100, we get 60.1% yield. Obviously not 100%. There are a lot of reasons for this. Could have been lost in the filtrate when there's the vacuum filtration. Some of the solid alum could have been lost in that liquid solution, and that could have been avoided if we had refiltered the filtrate to look for those solids, but we did not. The ice bath might have not precipitated everything, so that was this fourth equation. When the ice bath just precipitated out the solid alum, we could have not waited long enough for that to actually happen. And finally, some of the acid reactions might have not gone to completion. especially these two reactions could have easily not reacted all of the reactant enough, so we could have gotten less amounts of these products, therefore affecting the amount of reactant we have in the following equations. So yeah, 60.1% yield overall, which is not terrible considering, and now it is currently recrystallizing. Yay.